Hey guys, welcome back to Include Electronics with another video, and in this video we are going to make Arduino Bluetooth card using SC05 master slave transmitter receiver. We will pair two SC05 modules in master slave configuration to transmit and receive data. We have created remote control with two joysticks to send car control commands. So keep watching and I will explain it in detail with code. If you haven't subscribed yet, please hit subscribe button below and press bell icon to get latest updates. Let's first configure SC05 as slave for receiver. To set up SC05, we need to use AT command mode. For that, make a connection as per circuit diagram. Fix Arduino Nano on breadboard. Place SC05 on breadboard. Connect SC05 to Arduino as per pins in the table. Connect Arduino Nano to laptop using USB cable. You can see the SC05 is blinking rapidly. Now open configure SC05 master slave code. Inside this code we create object of software serial for SC05 communication. Inside setup function begin Arduino serial monitor communication with baud rate as 9600. Then begin SC05 communication with baud rate as 38400. This is required when SC05 works in AT command mode. Inside loop function, read data from serial monitor and write it to SC05 serial. Read data from SC05 and write it to serial monitor. The code link is provided in the description below. Let's upload this code by selecting Arduino Nano board and port. Hit upload. Once uploaded, remove USB cable from Arduino. Now press and hold the enable button on SC05 and then connect USB cable to Arduino. You can see that SC05 continuous blinking stopped and it blinks slowly like once per 2 seconds. It confirms that SC05 is in AT mode. Now go to tools and open serial monitor. Select baud rate as 9600 and select both NL and CR option. Type the AT command, it will display OK, which means AT mode is on. Now type AT plus RM AAD to remove any paired devices. Type AT plus roll equal to 0, which will set the SC05 in slave mode. Set the baud rate as 38400 using this command. Type AT plus ADDR to get address of the slave SC05. Note down this address. Now let's configure SC05 as master for transmitter. Remove the previous SC05 module and connect another SC05 to be configured as master. Now press and hold the enable button on SC05 and then connect USB cable to Arduino. As you see, SC05 has entered into AT command mode. Now go to tools and open serial monitor. Select baud rate as 9600 and select both NL and CR option. Type the AT command, it will display OK, which means AT mode is on. Now type AT plus RM AAD to remove any paired devices. Type AT plus roll equal to 1, which will set the SC05 in master mode. Set the baud rate same as 38400 using AT plus UART command as shown. Type AT plus C mode equal to 0 to connect to only our slave SC05 module. Type AT plus bind equal to slave address to connect to slave SC05 module. Please replace colon with comma. That's it. Our master and slave SC05 are configured. Let's make a transmitter now. We will need following components: Arduino Nano, SC05 Bluetooth module, analog joysticks. We need 2 pieces. Breadboard, 7 to 12 volt DC battery, in our case LiPo 2S battery, double-sided tape and few jumper wires. Let's make a connection as per circuit diagram for transmitter. First mount Arduino Nano on breadboard. Now mount SC05 module. Now attach left and right joystick using double-sided tape. Take plus 5 volt and ground from Arduino Nano and connect to breadboard power rail. Connect SC05 module to Arduino pins as per table. Connect left joystick to Arduino as per table. Now connect right joystick to Arduino as per table. Attach battery to remote. Let's take a look at transmitter code now. Inside code, first we need to include software serial library. We have created BT serial object for SC05 communication and passed RX and TX pin number to it, that is D2 and D3. Then we have created packet data structure to store left joystick and right joystick input values to be transmitted. Inside setup function, we need to begin BT serial communication with baud date as 38400. We have created map and adjust joystick deadband values function. This function is used to map 0 to 1023 joystick value to 0 to 254. Hence 127 is center value which we send. It also adjusts the center deadband in joystick. Joystick values range from 0 to 1023, but its center value is not always 511. It is little different. So we need to add some deadband to center value. In our case 500 to 530. Any value in this deadband range is mapped to center 127. Inside loop function, we need to read joystick values. Then we need to create a string from these values and send using print function. Add a delay of 10 milliseconds. The code and diagram link is provided in the description below. You can upload it directly. Connect Arduino Nano to laptop using USB cable. Select Arduino Nano board and port. Hit upload. Now let's take a look at receiver. We will need following components: 4WD car kit, this car kit comes with car chassis, 4 TT gear motors, wheels, connectors and screws. We will also need Arduino Nano, SC05 Bluetooth module, L298N motor driver module, 7 to 12 volt DC battery, in our case LiPo 3S battery, breadboard, double-sided tape and few jumper wires. Let's assemble the car now. First let's solder wires to gear motors. Mount all 4 motors on car chassis using connectors and screws. Now attach both the car chassis plates using screws and make sure that it is tightened properly so that we don't have any loose part. Join red to red and black to black wires of DC motors on each side. Attach L298N motor driver module on car chassis now. Now let's make a connection as per circuit diagram. Connect right side motors to out 1 and out 2 pins of L298N motor driver module. Now connect left side motors to out 3 and out 4 pins of motor driver module. Attach DC battery power connectors to motor driver module to plus 12 volt pin and ground pin. Place breadboard on car chassis using double-sided tape. Mount Arduino Nano on breadboard. Place SC05 module on breadboard. Connect L298N motor driver module to Arduino Nano pins as per table. Connect SC05 module to Arduino Nano pins as per table. Attach wires to plus 5 volt and ground pins of motor driver module. We will take plus 5 volt and ground from L298 and motor driver module and provide to Arduino Nano and SC05 module. Attach wheels to car now. Let's take a look at receiver code now. Inside code, first we need to include software serial library. We have created BT serial object for SC05 communication and passed RX and TX pin number to it, that is D2 and D3. Then we have created packet data structure to store received values. Then define pins for right and left motors. Inside setup function, set the motor pins as output. Initially stop all the motors. Then begin BT serial communication with baud rate as 38400. Inside loop function, check if data is available and read it using read string until function. Left joystick y-axis value is used for speed in forward or reverse direction. Right joystick x-axis value is used for steering speed. We steer the car by adding x value to one side motor and subtracting the same value from other side motor speed. Constrain the speed to 0 to 255 PWM values. Now call rotate motor function and pass right and left motor speed to it. If data is not received from Bluetooth in 1 second, then stop all the motors. We have written rotate motor function which takes right and left motor speed as arguments. It rotates motor in forward or reverse direction depending upon positive or negative speed. The code and diagram link is provided in the description below. You can upload it directly. Connect Arduino Nano to laptop using USB cable. Select Arduino Nano board and port. Hit upload. Connect battery to car now. Provide power supply to Arduino through V-in and ground pin. That's it. Let's see how it works. Left joystick y-axis is used for throttle control. Right joystick x-axis is used for steering control. We need to remember following important points. Please use only rechargeable batteries. Hope you guys enjoyed the video and thanks for watching. Stay safe and please like, share, comment and don't forget to subscribe to my channel.